Hello viewers, I am Kausalya. Today we are going to solve problems related with coupled circuits. The problem is show that the circuit shown in figure behaves with respect to terminals A and B as an open circuit or as a short circuit if Xc equal to X2 or Xc is given by this expression. So here this is the given circuit diagram and here Xm is the mutual reactance that exists between these two coils. Right. So now we are going to redraw the circuit diagram. So when you redraw the circuit, you see here we are having X1, X2, right? And there is an Xc. So here whenever we are redrawing the circuit, the mutual inductance is generally represented as minus Xm here, okay, and similarly minus Xm in this part and plus Xm in the middle part, right. So again when you combine the reactances together, here we are getting the values as, you see X1 minus Xm and here X2 minus Xm and here Xm and here it is Xc, right. So now we are going to find the equivalent reactance across the terminal AB. So to find the equivalent reactance, you see here this inductor and this capacitor are connected in series, right? Because you see the same current flows through this path as well as through this path. And this combination comes in parallel with this Xm, right? So while writing the expression, what is the basic formula for combining the things in parallel? That is x1 into x2 divided by x1 plus x2, right? So here the value of x1 is here, so it is jxm, and x2 is, we are combining these two things. So x2 minus xm, since we are considering xc, here we are writing it as minus xc, right? So when you add all these things, x2 minus xm minus xc divided by, again you have to add, so jxm plus j into x2 minus xm minus xc, right? So here I am moving, that is I am multiplying these terms with the j. So when you multiply here, these two terms cancel each other and finally you see even the j term can get cancels and finally we are having an expression like this, right? jxm into x2 minus xm minus xc divided by x2 minus xc, right. So now you see we have combined, we have eliminated, okay, we have combined these three things together as a single reactance. Now that reactance comes in series with this reactance, right. So here, that is, now we are having two reactances in series, so just we have to simply add. So when you add, you see x1 minus j of x1 minus xm plus this expression, right. So the next step is we have to take LCM. So once you take LCM, that is we are multiplying this term with x2 minus xc, right. So once LCM is taken, next we are multiplying and we are cancelling the common terms. So here as usual the same thing, okay, this term we are multiplying these two terms, okay, these two elements, and here the same way we are multiplying these two things, everything we are multiplying. So after multiplying, I am taking this j as commonly outside since j is present in all the expressions. So here after multiplying and cancelling the common terms, finally here we are having the expression as, right, so j of x1 x2 minus x1 xc minus xm square divided by x2 minus xc, right. So here we have calculated the total reactance across AB. Now what is the question which is asked? Just when you look back, so what are all the conditions which are given here? You see, that is open circuit, okay. Open circuit means what is the condition? Xc is equal to x2. And if it is a short circuit, what is the condition? This is your condition, right. So look at this expression, right. So this is your net reactance. So the first condition is when you consider the circuit as open circuit. What do you mean by open circuit here? The value of this reactance have to be infinity, right. That is the condition for open circuit. So under what condition this term will become infinity? When the denominator term of this expression becomes 0, right. Sorry, becomes infinity. That is, we have to make the expression xab as infinity. When xab becomes infinity, when will this become infinity? When the denominator term is 0. Right. So when you use that condition, so here the denominator term is made 0. Therefore, the condition is x2 equal to xc. So under this condition, the circuit will behave as an open circuit. So again, for short circuit, the value of xab should be equal to 0. When the value of xab is equal to 0, what does it mean? So here xab is equal to 0 is nothing but this numerator term is equal to 0. Right. So when you make this numerator term equal to 0, right? Just again we are simplifying. I am moving this x1, xc to the right hand side. So once it is done, again the expression for xc is given by x1, x2 minus xm square by x1. This is the condition which is given in the problem, right? Therefore, both the conditions are satisfied, right? So here comes the end of this problem. We will proceed with the next one. The problem is, in the coupled circuit shown in figure, find the voltage across the 5 ohm resistor, right? So the same way that we have seen like a derivation. So here we are going to solve the problem, right? So as usual, I1 is the current that flows in the first loop and I2 is the current that flows in the second loop. We need to calculate the voltage across this 5 ohm resistor, right? So how to calculate the voltage across this 5 ohm resistor? We need to calculate the value of I2, right? So the first step is we are going to calculate the value of mutual reactance here. So the mutual reactance is given by k into root of x1, x2. So the value of k is given. The value of x1 and x2 we know, right? Here it is 5 and 10. So just substitute the values and finally we are having the answer as 5.66 ohms. Right. So the next step is we have to draw an equivalent circuit. So how to draw the equivalent circuit? We have to keep all the remaining things as such and we have to include the value of xm. Right. So xm here is minus j 5.66 and here also minus j 5.66, whereas in this part it is plus j 5.66. Right. So this is the important step which is to be noticed. Okay. This is your first step here. Then the next thing is we have to write it in matrix form. So when you express the things in matrix form, as we all know the same thing, here we are having 2 loops. Therefore, now we are going to frame a 2 by 2 matrix. So again, the first element here is we have to add all the reactants, that is all the values of elements present here. So here when you add, you see, anyway this minus and this plus they will cancel. So the remaining term will be J5 plus 3 minus J4. So J5 minus J4 will give you J1. Therefore, here the answer is 3 plus J1, right? Again, when you look at the second loop, these two terms cancel. They will get cancelled and the remaining term will be J10 and minus J4. So 10 minus 4 will give you 6, right? And 5 plus 3 will give you 8. Therefore, 8 plus J6. And here the elements which are common for loop 1 and loop 2 is these are the elements, right? So again when you look at the direction of current flow, I1 flows like this whereas I2 flows like this. They are opposite to each other. Therefore we should include a minus sign. So here when you solve, what happens? 3 remains as such 3 and 5.66 minus 4 will give you 1.66, right? Since here the direction is opposite to each other, here therefore here we are including a negative sign, right? So this term is filled and this part is also gets filled. I1, I2 which is equal to, and the voltage sources are here, first loop has 75 volt, therefore 75, and second loop has no voltage source, therefore here it is 0, right? So the next step is calculation of del, right? So the calculation of del is calculating the net value of your reactance part, right? So once you solve here, finally we are ending up with the answer as 11.08 plus j 16.04, right? I believe you people know how to find the value of del. The value of del is nothing but, okay, finding the determinant value of this matrix will give you the del here, right? So this is in rectangular form. I have converted this in a polar form. Then the next thing is we need to calculate the current I2, right? For that we have to calculate del 2. So del 2 is nothing but you have to replace the second column of this part by the respective sources. So here this is your source value. When you replace and solve, you see finally I am having this value, right? So I2 is nothing but del 2 by del. So just substitute the values here. Once you solve, here we are having the value of I2 as this thing, right? This much amps. So we need voltage across the 5 ohm. So voltage across the 5 ohm is, again when you look back at the problem, the voltage across this 5 ohm. Okay, how to calculate the voltage? Once you know the current, it is easy to calculate the voltage across this 5 ohm, right? So the current flowing through this 5 ohm is nothing but I2. So 5 into I2, therefore 5 into the value of I2 is this one. So just substitute the values here. And once you solve, the value of this voltage is nothing but 64.57 volt. Right. So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.